Look at another way to write a function, and that's by using an explicit formula for a sequence. Now, a sequence is simply a list of numbers that follows a specific pattern. For example, if I gave you the sequence 2, 4, 6, 8, ... you could easily tell me that that's just the pattern of even numbers. The first one was 2, the second one was 4, the third, fourth, fifth, so on and so forth. You could find that pattern or sequence. So a sequence is a function whose domain, remember domain is your inputs, is the set of all positive integers. In other words, the counting numbers, 1, 2, 3, 4. The output is known as the term of the sequence. All right, so our outputs here were 2, 4, 6, 8. Our domain was 1, 2, 3, 4, so on and so forth. All right, we'll get more practice at that in just a second. Now, there is specific notation around a sequence. It uses a subscript, and this is called the index number. It is the label that is set below and smaller than the normal text, and it indicates the position or the term number of that sequence. For example, T subscript 1, you can see that little lower case set below is that position number. That's the index number, so it indicates the first term in the sequence. All right, so here is a pattern of dots, and you can see that our first term value is 1, our second term value is 3, I'm going to write them out like here, our third term value is 5, I'm sorry, that's 6, and then our fourth term value is 10. All right, so if I keep writing out the number of dots here, I'll see that my first term was 1, my second one was 3, my third one was 6, my fourth one here was 10, and hopefully you're starting to pick up the pattern here of what we're doing. My fifth one here is going to be 15. Now we can keep going if we pick up that pattern and figure out what that is. Now it says here in example 1, T sub 1. In other words, what is the first term number? Well, that first term number was 1. The fourth term number we said was 10. Then T sub 9 would be the 9th term in that sequence. And the value of that would be by carrying this pattern forward and counting up the number of dots. All right, describe the pattern in words. How is each successive pattern or count formed from the previous pattern of dots? So if you take a look here, here's my previous pattern. If I'm going to form the second one, it looks like I'm taking it and I'm simply adding a diagonal row with the number of dots as that index number indicates. So I'm going to take that previous pattern, and for my third term, I'm going to take that previous pattern, and I'm going to add 3 dots, take that previous pattern, add 4 dots, take that previous pattern, add 5 dots, so on and so forth. All right, so what exactly is an explicit formula? An explicit formula describes any term in a sequence from its index number in the sequence, okay? And that's another way of saying its position number. All right, here is an example of an explicit formula. It says T sub n is equal to 3 to the nth power minus 4, where n is our counting numbers. And remember those counting numbers? Start at 1 and go 2, 3, 4, ... All right, so our first counting number here, our first position here, is going to be T sub 1. And it can be found by taking 3, raising it to the first power, and then subtracting 4. Well, 3 to the first power is 3, 3 minus 4 is negative 1. So we would say the first term's value is negative 1. The second term then would be found by taking 3 squared minus 4. That's going to give me 9 minus 4, which is 5. So T sub 2, or the second term in this sequence, is 5. The third term would be found by taking 3 to the third minus 4. That's going to give me 3 cubed is 27. 27 minus 4 is 23. Finally, the fourth term is going to be found by taking 3 to the fourth and subtracting 4. And that's going to be 3 to the fourth is 81. 81 minus 4 is going to give me 77. So the first 4 numbers in this sequence, or this list, would read like this: -1, 5, 23, and 77. All right, next up it says to evaluate T sub 10 and explain what it means. So T sub 10, in other words, the 10th position, right, or the value of the 10th term in this sequence can be found by taking 3 to the 10th power and subtracting 4. Now, 3 to the 10th power is 59,049, and we're going to subtract 4 from that. So that results in 59,045. And so this is the 10th term in our sequence. All right. All right, in our final example for today, we're going to take a look at using your graphing calculator to input a sequence. So here it says in our example, Alfonso has invested $750 for 1 year at 8% annual interest. If the interest is compounded semi-annually, that means twice a year, how much will he have at the end of 1 year? So we're going to use this formula that says A is equal to the principal amount or the initial amount invested, which is our $750, times 1 plus our interest rate, which as a decimal is 0.08, divided by 2, all raised to the 2 times the number of years that we've invested it. All right, so we want to know how much it's going to earn after 1 year of investment. And if I look a little bit further, I see that I also want to see how much that money is going to be worth after the second year and the third years. Finally, we're going to answer the question, how much will it be worth after 10 years? Now, in order to do this, we can take a shortcut using our graphing calculator. So take a second to pull up your graphing calculator, and we're going to go to our y equals again. Now, this sequence is really just a formula or an equation that we're going to enter into our y1 line. So we're going to start off by entering our initial amount that we've invested, open up a set of parentheses there, and now we're going to do 1 plus, and we're going to have another set of parentheses, 0.08, divide that by 2, close your parentheses again, and now we have to do a little exponent. Okay, so the exponent here is our little up arrow key, and in parentheses one more time I'm going to place 2 times x, because x is going to be our variable which represents the number of years that this money is invested for. All right, now I could go to the graph and look at the graph of that, but I'm not really interested in the graph. I'm more interested in the table. So we're going to press second function, table, and here we are starting at 0. Now 0 means that the 0 year, so how long has the money been invested for? 0 years, it's worth $750. If I go down to my next line, that's when x is equal to 1. That's after 1 year of investment. My $750 is now turned into $811.20. In the second year, I can see that that $750 is now grown to $877.39. And in the third year, I have $948.99. So I'm just going to slide this calculator over here, and we are going to copy down our solutions. Okay. On your notes, then you should make note that after the first year, that $750 was $811.20. After the second year, so our A of t here, oh, actually, you know what? Let's write this in sequence notation, not function notation. Our A of 2 then should be equal to $877.39. Our A of 3, our A sub 3 here, after 3 years, it's now worth $948.99. Finally, after 10 years, and I'm going to click back to my calculator here, I have to go all the way down to where x is 10. We see that our money is now worth $1,643.34, and that is the 10th term of this sequence. And this illustrates a very good point called the time value of money. You invest your money now at an early age, that money will grow and earn interest and be worth a lot more in the future.